Hello, I am Serkan Güldav. I am leading machine learning developments and implementation in USEPE project. Today, I will highlight some of these developments in this short presentation. For more details, we have documentation on our website. Of course, you can reach us directly for more information or any question. Here's the outline. First, I will explain how AI systems are structured. Second, I will talk about separation quality. What is it? How do we measure it? Third, briefly I will mention how USEPE machine learning plugin processes the information. Next, I will present results with verifications only for conflicts. Lastly, the presentation will end by conclusion. Let's start with AI systems. There are various phases of AI systems. Here I summarized it in 3 phases. First phase is data gathering. Data gathering could be stored data or can be collected by sensors in real time. Gathered datasets are used to train AI agent or machine learning model so it understands the system and offers possible solutions. In the third phase, system initiates an action or series of actions. In USEPE project, we developed and implemented for the first 2 phases of AI system. Our implementations can gather data and analyze it. The analysis evaluates the quality of solutions in terms of separation. Quality of the solution is measured by separation quality. Let's look at how separation quality works. Separation quality is a relative measurement of separation ranging from 0 to 1. 1 is perfect score, 0 means no separation at all. We obtain separation quality from 3 different perspectives. First one is pairwise score. This score is computed between all pairs. So separation quality of entire traffic is defined. Second score is general score. General score gives the separation quality of individual drones. It is for predicting domino effects of any change. Last score is local score. Local score is separation quality with nearby traffic. By this score, we can identify immediate dangers. All 3 scores are computed for 3 phases. Strategic phase before flights taking place. Therefore, path planning problems can be detected. Tactical phase is during the flights. Maneuver options can be scored to identify best performing option. Results phase is the phase after all flights are completed. In this analysis, overall effects of general changes such as airspace structure, resolution method, and so on can be evaluated. Now we can talk about implementations. The developed algorithm is called USEPE ML and implementations are named USEPE ML plugin. Third version of USEPE ML plugin is available for public use. Plugin is written for Blue Sky ATM simulator, so inputs are Blue Sky scenario files and Blue Sky log files. Plugin uses machine learning methods to measure separation quality. The results are served with verification parameters such as number of conflicts. Results are printed as CSV and PNG files. Let's check one of the outputs. In the results, we are going to talk about conflict-related outputs, but also loss of separation can be obtained to verify reliability of machine learning results. Here is an example for pairwise scores in summary phase. Type of drones in the simulation is DJI Matrix 600. In the simulation, 100 drones fly roughly 4 hours simulation time. For the plot, on the left hand side, horizontal axis shows the number of aircraft pairs and vertical axis shows the normalized values. Green line shows pairwise scores, gray dots shows the normalized number of conflicts. As you can see on the plot, lower scores corresponds to higher number of conflicts. For the plot on the right hand side, Horizontal axis shows aircraft pairs. Vertical axis shows conflict durations and normalized pairwise scores. In this plot, pairs with lower scores spend more time in conflict. Besides this, every plot comes with summary boxes. Summary boxes include information about separation quality and verification parameters. In these plots, we see conflict-related information. With last words, I will finish the presentation. If we list what we are having with USEPE, separation quality assessments are done quantitatively, implementations are designed and released for public use, it is freely distributed. Using implementations does not require any machine learning expertise. It provides information for third phase of AI systems, which is action. Therefore, fully automated system can be obtained. Thank you for your time and patience. If you have any questions or more information, please don't hesitate to reach me out directly.